Now we're going to start talking about trig on the unit circle. So we start out with a circle of radius 1. Circle of radius 1 centered at the origin. You will recall its equation is x squared plus y squared is equal to 1. That's the equation of a circle, radius 1 centered at the origin. Well, if it's got radius 1, then what's its circumference? Well, the circumference is 2 pi r, but r is 1, so the circumference of the unit circle is just 2 pi. All right, so how do we define an angle? Well, an angle theta is measured starting with the positive arm of the x-axis. And that's called the initial side. All right, so every angle is measured from the positive arm of the x-axis. And if it's measured counterclockwise, like this way, then the angle is positive, and clockwise, the angle is negative. Now, this is where trig on the unit circle is different than triangle trig. You'll never see a triangle that has a negative angle, but in trigonometry in general, there are negative angles. And also, there are angles that are bigger than 180 degrees, which cannot happen in a triangle because you know the sum of all the angles in a triangle is 180. All right. So the initial side is the positive arm of the x-axis. The terminal side, that's where we end, is where our angle stops. Okay, what does radian measure? Well, radian measure is actually the distance walked as you sweep through the angle. So if you think about that, if I start with the positive arm of the x-axis and I walk all the way around the circle, I have walked through an angle of 360 degrees. But what distance have I walked on the unit circle? The answer is I have walked a distance 2 pi. And that's where we get the equivalence. 2 pi radians is the same as 360 degrees. Now, if 2 pi radians is 360, then pi radians is 180. All right, so how does one convert from degrees to radians, radians to degrees? Well, it's this ratio, pi divided by 180. And if I start with degrees, if I multiply by pi divided by 180, I end up with radians. Or if I start with radians and I multiply by the reciprocal, 180 over pi, I end up with degrees. And that's the way you can convert from radians to degrees. All right, so with respect to angles, we have an initial side, we have a terminal side. Those angles defined by the same terminal side, if they have the same terminal side, they're called coterminal angles. Get it? And coterminal angles have the same trig values, and we'll find out why. What are coterminal angles? Well, one angle, theta, might be from there to there. What's another angle that's different but coterminal? Well, I could start here, go all the way around 2 pi and add another theta. Or I could go around a couple of times and add another theta. All of those end up with the same terminal side. So if theta is my angle, well, what do the coterminal angles look like? Theta plus or minus 2 in pi. And that's talking radians. Which, by the way, is what we're going to be talking for the most part. Why? Because every formula in physics and calculus that deals with angles is created using radians and not degrees. So in fact, if you use degrees, more often than not, you're going to be wrong. All righty, now let's hit definition 2.4. I have an initial side, positive arm of the x-axis. I have a terminal side. That terminal side cuts my unit circle in exactly one spot. And that spot is defined to be cosine theta, sine theta. So there's theta. Then the coordinates are cosine theta, sine theta. And that's how one defines cosine and sine. Now, you'll notice that this point is on the unit circle. Well, if it's on the unit circle, then it satisfies the equation of a unit circle. And recall the equation of a unit circle way back up here at the beginning of the chapter was x squared plus y squared equals 1. So now if I realize that x is cosine theta, y is sine theta, I get sine squared plus cosine squared is 1. And that is our first Pythagorean identity. All right, now I'm going to look at points. Once I know the definition of cosine and sine, they all depend on this angle theta, we can now compute values of cosine and sine. So let's look at, first off, the angle 0. That means I don't move from the initial side. Where does that intersect? The unit circle at the point 1, 0, but I know that that corresponds to cosine of the angle 0, sine of the angle 0. And that's where I get cosine of 0 is 1, sine of 0 is 0. Now what about pi halves? Pi halves is 90 degrees. That's up here then. That corresponds to the ordered pair 0, 1. Well, so that tells me that the cosine of pi halves is 0 and the sine of pi halves is 1. What about the angle pi? Well, the angle pi starts here and goes all the way over. We walk halfway around the unit circle. That corresponds to the point -1, 0. And that's how I know that the cosine of pi is -1 and the sine of pi is 0. Now if I go 3 pi over 2, 3 pi over 2 is walking from there all the way over to here. So it's got coordinates 0, -1, hence cosine 3 pi over 2 is 0, sine of 3 pi over 2 is -1. Finally, if I walk all the way around my circle, I'm back at the same spot I started, and that's back at the point 1, 0. That tells me cosine of 2 pi is 1, sine of 2 pi is 0. Notice that 2 pi and the angle 0 both begin and end at the same spot. They are coterminal angles, which makes sense. All right, so from the definition of sine and cosine, it's not hard to see that since they end at the same point on the unit circle, if two angles are coterminal, they have the same cosine value and they have the same sine value. What's another thing that we can notice? Well, okay, so suppose I take an angle theta, which means I start here and I walk up. Cosine of theta, sine of theta, that's the coordinates of this point. Well, what if instead I walk in the opposite direction? Remember, my angle is negative if I walk clockwise. Then this point would correspond to cosine of minus theta, and this point would correspond to sine of minus theta. Well, let's think about this. This x value is the same as that. So cosine of minus theta is the same as cosine of theta, whereas this y value here is positive. This y value is negative, but it's the same in absolute value. That would tell me that the sine of minus theta is minus sine theta. And there are a couple other trig identities. So by figuring out where on the unit circle you are, you can compute the values of sine theta and cosine theta, depending on theta. Well, I'm going to talk a little more about that in my explanation of this chapter, but I'm going to stop here.